Welcome back. I left you with a cliffhanger with the number one problem with protecting wireless networks, what they're most susceptible to, the type of attack, is specifically, of course, the evil twin attack. This is why I have the ridiculous picture here. So, which one of these twins is evil? Well, obviously the one with the beard. Why is that funny? Well, it's a nerdy callback to the original classic Star Trek episode, Mirror Mirror, where there's an alternate reality where everybody's their opposite and Spock is evil, and the only way you can tell evil Spock from good Spock is evil Spock has a goatee, which is why a lot of IT people wear goatees now. I don't know if that's true, just my sociological stupid theory for the day. Anyway, it's called an evil twin attack, and let's kind of step through this quickly. The evil twin inserts itself and tries to get the victim to connect to it instead of the legitimate access point. You can set up anything as an access point. You can set up your laptop as an access point. You can set up a Raspberry Pi as an access point. You can set up your phone as an evil twin access point. You just have to give it the same SSID, right? That somebody's going to try to connect to it. The evil twin intercepts it, decrypts it because they initiated the connection. Therefore, they've got the encryption key, and then re-encrypts it and sends it on to the AP. Now, that is, and then the access point is going to send it to the legitimate server. The problem here is it's this area from the from the mobile device to the access point that's it's hard to defend, and that's where an evil twin attack occurs. This is the same thing as it's a variant of a man-in-the-middle attack. So my apologies for the gendered language. I should say person-in-the-middle attack. It sounds a little weird, but a man-in-the-middle attack is anytime you're inserting something between to intercept a transmission is a man-in-the-middle attack. So the evil twin access point is just a flavor of a man-in-the-middle attack. What makes it so evil? Well, that the client, you, the good guy, encrypts the traffic like they're supposed to. The evil twin manages to decrypt the traffic, reads it, saves it, and then sends it on. It sends it on. So the traffic, the message you sent does get to its intended recipient. It's not like it's grabbed out of the air and stolen, and you're like, oh, why didn't that packet get through? It goes through, which is why it is so difficult to see when this attack is taking place, because the traffic goes where it's supposed to go. It's hard to defend against, precisely because we don't have any end-to-end protection. So remember, all these protocols we've talked about so far just do protect this area here from the wireless device. And now, why do we have a desktop icon for a wireless client? That's ridiculous. That's why I hate using publisher slides, but I'm lazy, so I'm just using publisher slides. But this is the danger zone, if you will. There's no end-to-end protection to protect the entire transmission from here to the server. Is there a way to protect the transmission from end to end? Yes. The answer to that is, well, one would be to use a private network. That'd be the best thing to do, but that's super expensive. But what's not so expensive is to use a virtual private network. So you're pretending to set up a private network. It's not really a private network because it's still going over the public network, but you're encrypting it end to end, which it's almost as good as a private network. Not really. It's still, this isn't perfect, but it's the best thing we've got. What's the answer to an evil twin attack? Well, run a VPN. That's the best thing you can do at this point. It makes it much more difficult for somebody to intercept the transmission, which is why I would say, and this is not in the textbook, but this is just real world stuff here, just a tip from your Uncle Tim. What you want to do is treat all these mobile devices, all these wireless devices, as if they are outside the network. Just outside the firewall. They're not to assume that they're inside the network and kind of bring them in through the back door, I think is dangerous. So, for example, this mobile user should always go through, so like a Cisco VPN client, any sort of VPN client, in order to get to the corporate network, as opposed to just connecting to an access point and boom, you're on the network. To go through some kind of VPN appliance, some kind of UTM, Unified Threat Management Device, a firewall, a VPN concentrator. Different manufacturers are going to call these different things. Some companies do this. Smart ones do. Not everybody does it this way because it's an additional layer of complexity to bring all your mobile users in through a VPN. But I think more and more this is the way you've got to do it. So if you're in a hotel, remote users, home users for sure, kiosks in a store need to do this, to bring in all your wireless traffic through a VPN. I would say is a best practice at this point. Now, we've got a couple of videos here to wrap up with. I guess I will go ahead and show these to you instead of assigning, just so for convenience, I'll just go ahead and play them for you. One is just a quick, if you didn't like my explanation of an evil twin attack, this is the most important thing in the chapter. We've got another explanation to show you, and then throwing caution to the wind, and I want to show you exactly how to do an evil twin attack, step by step, of course, using Linux. This is the kind of stuff that probably the school doesn't want me showing you, but I'm going to show you anyway, just because know your enemy, right? You've got to understand how this stuff works, at least a high level. So let me cue this up for you. All right, here we go. Let me set the volume here, and we'll try this out.
So Andrew, now we're doing this sort of evil twin demonstration, and I'm in a hotel, and I want to access the Wi-Fi, and I go to my computer, and I see in this little box here, oh, here are all the Wi-Fi access points that are available to me, and one of them is called typical hotel Wi-Fi.
Sure.
So I click on that because it's got a lot of good bars, and it looks just like the hotel I'm in.
Well, looking exactly like the hotel you're in is exactly the point of the evil twin attack. So the attacker creates a Wi-Fi network that has the same name as either Wi-Fi networks in the area or
same
Wi-Fi
SSID is the
previously
name.
connected to. They make their signal stronger than all the other networks in the area, so you're more likely to connect to them. And then once you connect to them, all of your internet communication passes through the attacker's network, through their computer, so they can monitor and modify any of your communication.
So here it's asking me for, my email address, my password. They're able to see all of that when I enter it, but more than that, purchase access for $5 for 3 hours. If I purchase it, I've got to give them my credit card, at which point they have my credit card, expiration date, CCV code.
If you were in a hotel that provided free Wi-Fi, you might recognize this as being not expected, right? Like normally they would ask you for something like your room number and your last name. It's a very reasonable request. But in this case, they're asking you for payment card details. If you're expecting free Wi-Fi, at that point you should probably give the front desk a call.
Take me through that again. The hotel I'm in will probably show up here.
Sure.
The fake hotel, the typical hotel, will also show up here. How do I know which is which?
There's no way to know which is which. They'll be virtually indistinguishable.
So does that mean that I just shouldn't use free Wi-Fi in hotels?
I
Right.
wouldn't say don't use free Wi-Fi in hotels, but you should definitely take steps to protect yourself. So you should know if this hotel provides free Wi-Fi, and if so, what should be required in order to access the free Wi-Fi. But if you're expecting free hotel Wi-Fi and you're being asked for credit card details, at that point you might want to bail out.
Just no Wi-Fi is safe ever.
No, of course I use Wi-Fi, but I tend to compartmentalize what I do on public Wi-Fi versus the Wi-Fi in my home. So when I'm on a public Wi-Fi network, I don't do my online
Don't
banking.
touch your face.
Mostly I would recommend, if it's a particularly sensitive function, if it's online banking or something similar, I don't do that on public Wi-Fi.
Okay, so some good tips. And what should he do? He should use a VPN. So that's what I do when I'm out and about. I pay a subscription to Proton VPN. That's what I use. I'm not recommending it. You know, there are lots of tools out there, but you probably want some kind of VPN tool. But let's get to the how-to. How do you commit this fraud? I mean, how do you do this penetration test? That's right, because we're white hat hackers.
Hey guys, Hackersploit here, back again with another video, and in this video we're going to be looking at how to perform the evil twin attack. Now this is going to be one of my last videos in the wireless penetration testing on WPA2. So we're going to be taking a look at how to perform the evil twin attack in this video, after which in the next video we'll be taking a look at how to perform a man-in-the-middle attack on a WPA2 and obviously on a wide network. So we'll be keeping that for the next video.
Hang on. Sorry, I needed to rearrange things to get my head out of the way so you can kind of see what he's typing. I know it's going to be small, but he'll say what he's typing in here.
Now, I do apologize for the lack of consistency over the last 2 weeks in regards to the schedule. I've been working. If you're not familiar with what an evil twin attack is, let me explain it simply. The goal of this attack is to essentially duplicate a network, a wireless network, and you're essentially trying to spoof the network name and its MAC address in the hope that clients will connect to your access point. All right. So, for example, this can be, we can use a very simple example. If you're at a coffee shop and you are essentially getting clients to connect to your wireless network, how would you go about doing that? And this is where we talk about the evil twin attack. So your goal is to duplicate an already existing network so that you can get rid of the authenticity, and it is also a form of social engineering. So if you're at a coffee shop, let's say their Wi-Fi network is called Coffee Shop Wi-Fi, just something simple. I don't want to use any brand names. You will essentially get their router or access point MAC address, and you will spoof their network name. And then you're going to use the deauthentication attack to deauthenticate clients from the network. So when they reconnect to your access point, after which you can then perform a man-in-the-middle attack on them and intercept their traffic, as now you are the access point. So all their traffic is being directed to you. Now, as I said, the man-in-the-middle attack is primarily the second step of this attack, and I'll be covering that in the next video. All right, so essentially what you're trying to do here is you're duplicating a network with the same network ESSID and the BSSID, which is the MAC address. All right, so we're going to be using the aircraft suite.
Remember that.
We'll be utilizing AeroDump NG and Airbase NG. Also IWconfig.
Sorry, I keep hitting the wrong pause button. What he said there is important for the next exam. The difference between the SSID and the BSSID. The SSID is the name of the wireless network. The BSSID is the MAC address of the access point. That's important. So let me back it up here to. Okay, sorry about that.
Utilizing AeroDump NG and Airbase NG.
Okay.
So I already have my wireless adapter set up, and
these are free tools.
It is in monitor mode right now. So IWconfig, that'll open it up, and it is currently on WLAN 01. All right, so we're ready to go. So make sure you have your interface in monitor mode if you don't have it already. So we're ready to go. So remember, we are going to be targeting a particular network and its clients. So to do that, I'm going to be targeting my access point here. So AeroDump NG. I'm just going to show you the current name, and already have its access point BSSID, which is the MAC address. So essentially, when using AeroDump, we are specifying the network we are targeting and its clients. So we specify the BSSID. You can also specify the channel if you want, and I'm going to specify the access point, the interface that we're going to be using. I'm going to enter. All right, and the reason I'm doing so is because, as I said, I don't want to essentially disclose any of my neighbor's Wi-Fi networks, and as I've mentioned before, my blurring skills are not really good. So this is the network we're targeting, and we are seeking to duplicate or create an evil twin of. It is my network. It's called Alexis Broadlink, and we have the BSSID right over here, and we currently have one client connected to it. All right, so we are trying to replicate or duplicate this network. So to do this, I'm just going to split this up, and we'll leave AeroDump running over here. So let me just zoom in a bit here so we can actually see what's going on. So we're going to make use of Airbase NG now. So Airbase NG is very simple. So we're going to say Airbase NG And after this, we now need to specify the access point that we want to spoof. We need to specify its MAC address, and that is done by the A command, as we did in the previous video when we were talking about the authentication. So we want to spoof this MAC address, and we also want to spoof the ESSID or the network name. Now we need to specify the network name as the same, which is very, very important. So ESSID, and we put the name into quotation marks, otherwise the name will not be able to specify it correctly. So Alexis Broadlink, and we'll close the quotation marks. We then need to specify the appropriate channel. In this case, the network is running on the channel 1 over here. Now, if you are going to perform the deauthentication attack, it is recommended that you run it on a different channel, but for now, let's run it on channel 1 here. And we are going to specify the interface, so WLAN 01 and hit enter. For some reason, that is telling me, yeah, that is a incorrect spelling. That is not air, that is airbase. So I'm going to hit enter, and there we are. All right, so it's going to start the access point on that particular, it's going to start spoofing with the access point MAC address. So if we restart the aerodump ng session here, and we also specify that we are looking for that particular MAC address, or we only want to scan for that particular access point, you can see something interesting happening right over here, that the channel will essentially be moving from channel 1 all the way to channel 13, 14, the entire range of channels, and that means that the attack is working. We have created 2 separate networks. Now, of course, this is going to be, it's not going to be visible when trying to actually display the current networks. It's going to display as one. And that is where the deauthentication attack comes into play. All right. So essentially, for the deauthentication, we are simply going to send a deauthentication packet to the access point, or to the legitimate access point, after which it is going to be deauthenticated with. And since we are only spoofing, we are not going to get deauthenticated because we are not the access point. So any client connected to that target is going to get it kicked off the network and is going to connect to us, because the settings are same to that of the access point. So I'll show you what I mean.
Okay, that's the key of the attack. So the access point has to be susceptible to this type of attack. Now, it might be patched. It might have a level of firmware where it's not susceptible to the deauthentication attack. But the idea is, if your laptop, your device is spoofing that access point, same MAC address, same network name, SSID, that if you send this magic packet to the access point to bump everybody off very quickly, to deauthenticate them, to kick them off the network, when they immediately, because this is the way the protocol 802.11 protocol works, is they're immediately going to try to reconnect. They're going to reconnect to you, typically because you've got a stronger signal than the access point, because you're sitting closer to where the people are. So they're going to connect to you, and now you've got them, right? Also, I misspoke before when I said like BSSID and SSID were things that are going to be on the next exam. That'll be on this exam, on exam number 2, because that's stuff that's in chapter 6, which is in scope for exam number 2. So just to be clear about that.
In a second. So right now, the current device that's currently running on my access point is my mobile device, which is what I'm going to be using. So let us actually deauthenticate this device right over here. But to do that, we're just going to deauthenticate all devices. So we're going to be targeting the access point. All right. So to do that, we're going to be using AirPlay NG. And of course, we are specifying the deauthentication mode, which is done by using the 0 command, or 0 parameter. We're going to send 5 packets, and we're going to specify the access point MAC address right over here, and the interface that we're going to be using, which is WLAN 01. All right, so after deauthentication, what's going to happen is the client is going to connect to connect to the evil twin network. All right, now I'm just going to run that one more because I do not have my network up and running. So that seemed to have worked. So I'm going to connect, and voila, you can see that I have connected to my evil twin network, with my mobile device, and that connected automatically. I simply just turned on my phone, and that was connected automatically. All right, and that's pretty much how an evil twin attack is carried out. Now let me just.
Okay, we can stop there, because I think you've seen the meat of it and how pretty straightforward this stuff is, frighteningly so. Okay, so hit me up with any questions you've got. And oh yeah, I need to give you some kind of Easter egg out of this session. So your Easter egg for course engagement points, just to keep things interesting, go ahead and accept the invitation to Microsoft Teams. Get into Microsoft Teams and just say something. Say something so I see you in the feed. Just, hey, just, let us know how life is going for you. Just be friendly. Just be friendly in Microsoft Teams. That's your Easter egg. I will let you go for now because we're already at 20 minutes. So hang in there, persevere. We're going to get through this together, okay? Bye-bye.